based on your tolerance for risk, right? Because like I said, you don't want something to take 10 minutes. Why is that?
You had the Mike Pence fly. The Mike Pence fly just showed up in your face.
I did, yeah. Hello, and welcome back to the Networking Podcast. Today, we're doing another episode of Best Effort. So this is going to be a bit of a mini-series within a series here.
I like it.
You like it? Yeah. We're running out of forwarding classes, so we didn't want to go and break out another forwarding class just for this. But this one is going to be a doozy. Today we're here talking about network automation, and that sounds generic. It sounds like we could be here for a while, but we won't. I promise. We're going to keep this under an hour.
Are we? Because I was going to say the first time we tried this, how long did we talk for? Over 2 hours, I think, right?
Yeah.
Our very first recording ever for this podcast was on this topic. We turned the mic on and we recorded for over 2 hours. And that's unreleased content, which maybe will get released at some point. So, we just decided it was too much. So we're going to try and break this up into, like Bruce said, a mini series.
Yeah, exactly. So I don't think we need to do intros at this point. You guys know who we are. If not, you can go hit up our website or our Twitter or any of our other social
Which you can
medias.
find here.
ntwr.kn, baby.
There it is.
All right, so let's dig in because we do want to try and finish this within at least 3 hours, I think.
Yeah.
So yeah, we are going to break this out across a few different podcasts. This one is kind of more intended to be a bit of an overview. The various areas, yeah, exactly. The various areas of network automation and what's going on in the industry and where we think there's momentum and where things have stagnated, all that good stuff we know you guys are interested in. So that's what we're going to be talking about today. And then because obviously network automation being the hugely vast topic that it is, we're going to have more kind of low-level detailed podcasts on the various areas and I guess projects that are out there that are focusing on this as kind of derivatives of the series. So that's kind of our plan. We will dive in a second, but before we do that, we did have some comments on some of the previous podcasts. Nick Conf, VG, and a Mike got quite a bit of a stir, a bit of a buzz.
Yeah, I did. That was a good one. We got a lot of comments and a lot of feedback from people on that one, which was really appreciated.
It was, yeah. We love to hear what you guys are thinking and what's useful and what's not. I mean, we're only really doing this for you, as fun as it is. And don't get me wrong, it is fun. But without an audience, it might be it definitely would be quite lackluster. So we definitely appreciate the comments. So I'm going to rattle off a couple that I thought were worth pulling out. Mark Siri on YouTube. This was on NetConf GNMI actually. He wanted to know about kind of a potential evolution from management interfaces for driving kind of control plane automation. I see you grinning. Versus kind of these model-driven interfaces. And, Mark, that's a great question. And I highly recommend you go have a listen to our centralized versus distributed control plane episode, because that's exactly what I was trying to dive into, but Erwin here didn't really let me. He kind of shot it down right at the forefront. So no, that's definitely it's definitely an interesting topic, and it's one I think we probably need to do a genuine follow-up on. To give that podcast some context, I think PSEP for kind of segment routing versus driving that change via something like NetConf or GNMI or ... And standardization is very interesting there, and we have an episode on data models, so that might be worth having a listen to as well. But we will come and circle back on that, Mark. So thanks for the comment. Next, a comment from Jeff Tansura, or at jtansura on Twitter, around our 128 technology acquisition episode, and there were other companies in that episode, so I don't want to pretend it was just them, but. He had some comments around how the high scale was achieved, and I know you read this comment, Aaron. What were your kind of initial thoughts on this?
Well, I mean, his initial comment was valid in that we described, and again, I should just highlight the fact that what we described is how we interpreted that it worked, and there's very high, not very high, there's a chance that we interpreted it incorrectly, but we had made a comment that the way they do this is through natting, which I believe it still to be true. They don't use overlay. They NAT everything. And of course, when you start NATing everything and you're doing PAT or source NAT, then you're limited by the amount of source ports you can use for every session you create. And that was Jeff's comment, was, well, how do you scale your NAT sessions out of a single uplink IP or a single IP if you're limited by the amount of ports you can do? So theoretically, you'd be limited to, under 64,000 sessions per single northbound IP that you were NATing out of. Mm-hmm. Which is true, right? That makes sense. So I guess there's a couple ways that I thought maybe they could solve it. And the one that you brought up was that we could have multiple IPs, right? So obviously that would be 65,000 or 64,000 per IP. So you could scale up that way, which obviously could work. I thought maybe and this is not, I have no idea that this is true or not, but I thought that because of the fact that they're storing that source and destination port in the metadata with the source and destination IP on that first packet that we talked about, that they would be doing both source NAT and destination NAT. And because of that, they could actually rewrite the destination port to be whatever they want, because when it gets to the far end 128T router, they could rewrite the actual original port, which they stored based on the first packet, which contained the metadata.
Right. That seems
something like
that,
that,
though, right?
It does.
Because you have to do that in software. I mean, it's a software data path anyway, so I don't know what I'm saying, but it seems like you're relying on
could be
metadata.
Expensive.
Yeah, it's going to be
but they're doing
pricey.
it. They're doing it for IP, right? So they're doing it already for remapping the correct destination private IP on the far end. So really, you're just adding it. You're doing it on an extra field, which would be the port in this case. And if that's what they were doing, obviously the amount of sessions would be much larger. For every source port, you could have a combination of 64,000 or 65,000 destination ports. So that would no longer be a concern from a NATing perspective or how they're doing it. But again, I have no idea that that's how they're doing it. That was my first thought when I read that comment from Jeff. And again, we could look into it maybe and get a better answer, but.
Alrighty. Well, we're not here to recap that episode anyway. So.
We're not. But we did get another. I mean, I think you spoke to a common friend of ours who also addressed his concern with scale. So like just in the same way that you brought up in that episode, there seems to be a general consensus that solution may be hard to scale and maybe an unknown to us as to how they're actually going about scaling it to the numbers that they've published. So.
Right. Yeah, makes sense. And there was also just a lot of other comments, I guess, thanking us for doing such a wonderful job breaking down all these technical topics. Those, of course, are massively appreciated. Again, we're doing this for you guys, so if there's any other topics in particular you would like us to cover, we've done a pretty good job so far of actually really tackling most the suggested topics that have been thrown at us. So we plan on continuing that trend.
And we have we have a very special guest lined up coming up soon, hopefully.
We do indeed.
If we can schedule it, we'll have a very cool episode coming up.
Indeed. Alrighty. So let's jump into network automation. I think that's as good a segue as we're ever going to find.
Yep.
All right, so I guess to start this off, to try and break it down, because we could ramble all day on this topic, and we did in that first episode you were mentioning. We kind of went around a bunch of different areas. Obviously, I guess to put it at a high level, I guess what are the different areas of network automation? Because we typically think of it as just configuration, right? Like I guess us as an industry, that's been what we have solved for. That was kind of the easy thing to solve for, I guess. And maybe there was some event-driven automation as well. But I don't know. What are your thoughts on what this should cover? What should we be talking about today?
Yeah, so I kind of thought about this a bit before this podcast, and kind of broke down network automation for me into 4 categories. And a lot of them overlap in terms of the tools you use, in terms of the methodology, how you go about, automating and so on and so forth. But to me, there's kind of 4 areas in which you would start your automation projects and journey, right? Yeah, exactly. So the very first one I have is config generation and deployment. So basically automating the process of generating all your configs, whether it be from templates, Python, any kind of scripting or programming language to generate these configs, and then tie that into how you actually get those deployed on boxes from an automation perspective. How do you automate bringing up a device? So ZTP, that kind of functionality.
Right.
The second category I had was service creation and ongoing changes. So how do you automate? In some environments, you're not really creating that many services. In some environments, you may be creating services on a regular basis, or you may be making changes to your devices or network in general on a regular basis. So that's a category on its own for me. Third, I had operations, so one-off scripts, right? Where you want to do something very quickly, I had to pull information from all your devices, maybe push a one-off change that's out of the normal day-to-day operations scope. That will fall under the operations and one-off scripts category. And then the last one was troubleshooting, auto remediation, that type of area. And that's, I think, an area that you have a lot of interest in and we'll talk about. So yeah, those are my kind of 4 areas, categories into which you would use network automation.
All right. That makes sense to me.
How about you? What were yours?
I think, you definitely hit at least 3 of the 4 that I was thinking of. I was thinking that there's a potential, and maybe you were just lumping it into your building configuration category, but there is at least a design level automation that I think can occur as well. And this could be as simple as generating cable maps and things like that, but could be more complex in that, actually plugging in speeds and feeds and building topologies in an automated fashion. I will caveat that, of course, by saying that most networks, that's utopia, right? I mean, we see that a lot in data center, of course, but outside of that, outside of maybe that kind of the backbone where you have, like ladders and those kind of topologies, it's much harder to do. And often the complexity of figuring out your automation story from a design perspective doesn't give you enough on the tail end that it's worth doing. You'd really have to be using it for a long time. And often our networks are changing faster than the automation tools can keep up with. So,
and I feel like data center is well suited for that, right? Because data center architectures tend to be fairly easy to replicate. It's a fairly standard way. You have a fixed number of uplinks, a fixed oversubscription ratio, speeds and feeds, and for you to automate, what that looks like seems to be like a kind of the low-hanging fruit for the design aspect of it.
Okay, so we should probably pause here for a second because I have a very, very important question for you.
Uh-oh.
Is it Kloss or is it Klo?
It's Klo.
Damn it, I knew you were going to say that.
Why, is that bad? What would you say?
I've always called it Kloss, always.
Well, it depends. It's some dude's name, so that's how you pronounce the dude's name. So I don't know.
Yeah, we should probably find the dude. I don't know if he's still around, but we should probably find him. Reach out to him, ask him how his name is pronounced. Yeah, why not? These are the things that keep me up at night,
I think he's elderly if he was still alive.
That's okay. I'm sure he's still got his wits. He came up with this design, right? It's pretty clever.
True that. All right. So Klo, let's continue with our Klo topology, and that's an easy topology to automate in terms of once you feed it, you put in a bunch of values, it can auto generate cable maps and auto generate which devices, as long as it knows some basic information about speeds and feeds and offerings. And
yeah, and then I guess often when you're building out additional pods within a data center, being like a cluster of tors and additional spines, they're often built out exactly like that as a cluster. So you can often kind of change your speeds and feeds and stuff at that point and kind of extend the data center just by building out additional pods. So yeah, data centers are definitely they're a great use case for automation at the design phase for sure. I think there's no disagreement there. We'll move on from design.
Keep going. We'll come back to this. Go through your categories. Maybe we can dig into each of these a bit more.
Okay. Yeah. So I had a very similar category to you as your first one, which was around building configuration, initial deployment of configuration, like you said, templatizing and being able to, I guess, build a configuration on the fly based on some kind of topology information. And I guess that's also linked because this is the first time you're actually interacting with the network, right? You brought up a good one, which was zero-touch provisioning or ZTP. And I don't know if it's worth going into detail about what ZTP is, but just for the audience who maybe haven't heard of it, because I wouldn't say it's a new term, but it's a term you hear more in the data center and less so kind of outside of the data center. ZTP is the general idea that you're basically at a high level, PXE booting your network. So, devices come up, they DHCP, where you potentially can re-image them at a ZTP time. In fact, that is used quite a lot. But a big part of that is your network. You PXE boot a Tor. I shouldn't say PXE boot because that's actually not what it is. This is not pre-execution at all.
Yeah,
it's not
exactly.
pre-execution at all. But
the general
the
high-level
concepts
concept
are
is the same.
Yeah. So, your switch comes up, it boots into an operating system, a service kicks up, reaches into the network, does a DHCP, maybe grabs down a script, or, phones home. And of course, this is the beauty of ZTP, is that it's very tunable, very customizable to your environment. You could hit a web server and post your serial number, and then it could push down a configuration or ... There's a million different ways to do this. A lot of vendors have implementations of ZTP these days, and there's also a lot of custom implementations. Like I said, it's very easy to tune, very scriptable. So this is kind of the first time you're interacting with the network, and I think ZTP is a big part of it. In terms of, because we are talking kind of the initial deployment of configuration here, what do you think about the different ways of doing this? And maybe this is going to be very, very subjective, I think. But there's kind of two approaches. One is that you phone home and you get like a push over an interface, whether it be like a model-driven interface or something like that. So you have something that actually kind of configures you. And another approach where you push down a file, or you curl or wget a file, or FTP, whatever the transport is. You pull it down and then you load it. So those seem to be the two common approaches for ZTP. What are your thoughts on the two? Any pros or cons either way?
Well, I think you need to pull down a base config before you have a northbound interface available most of the time. You can make northbound interfaces available on like a base config that loads up by the switch, but yeah, I don't know if I really honestly, if during ZTP you're going to be pulling down software images, I don't see an issue with pulling down a config. It means you have to have a config pre-generated before the ZTP process happens. Or you could have this as part of some sort of build pipeline where actually when the ZTP process starts, it actually kicks off the generating of the config. Yeah. I don't really know that that's something that's used much in industry, but I mean, I don't see why you couldn't really do that. So I don't know. I think, to be honest, I don't have a strong opinion on either method of doing it. I'd be happy with pulling down a config, which is maybe like my standard config, which has been generated ahead of time during ZTP, and just loading that when the operating system boots up. And I'd probably just be just as happy to, as part of the ZTP, call home when I feel that I'm ready to be configured, and then have something else kick off remotely that pushes down a config for me.
Okay.
Yeah, I don't know.
So no strong feeling somewhere or the other.
No. How about you? What do you think about that? Is it?
Yeah, my only thought, and again, I don't think it matters that much, but my only thought was that if you're going to end up doing anything beyond your base configuration, you're going to likely need to solve for using the management interfaces as they were kind of intended to be used, like GNMI or Netconf or any of the other ones that we covered in the previous podcast. And I'm big on code reuse, so. It's less kind of testing phases you have to cover. Your test matrices go down, and you often get better coverage. So I think if I were to design this on the fly on this podcast
right now, as we're designing the world's largest data center, go ahead.
Yeah, I would probably do exactly what you said, which is push down enough configuration to bring the system onto whatever management infrastructure I'd defined.
Yeah, and enable logging, enable all that stuff as your base.
Yep, exactly. And just enable something like GNMI or one of the other management interfaces. And from there, I would start pushing down the actual kind of like service underlay, ACLs, routing policies, whatever else I'm pushing as part of my, this router's configuration. I think I would do it through the management interface at that point. And
so yeah, sorry, go ahead.
Yeah, and I don't think it's wrong one way or the other, to be fair. It's just that you eventually, when you get to day 2, there I am more opinionated, and I don't think you should be pushing down an entire configuration file to load it every time. And I know that there's many, many tier 1 customers that are probably disagreeing with me right now, but I think that's a result of the systems that are in use, and not necessarily because that's the subjectively right or objectively right thing to do. So
but let's take a quick step back. Let's take a quick step back before you go any further down that path about day two, or the kind of how you go about adding services or day-to-day changes. Still during that first phase of ZTP, if you have a mechanism in which you are validating the state and you're expecting a potential state, you're expecting a specific state when you make a configuration change, you could have a strong case for doing this in your opinion, where you make the change after the fact. So if you have a system in place in which during ZTP you bring up a base config, you enable all your logging, all your management stuff, and including GNMI or whatever protocol you want to use for management or configuring. And then in a second step, as you bring the rest of the config online, you're actually validating the state as you're going through it. Then in that case, I could see a strong case for doing that, in a second step. Bring the device online. I'm now going to start making other changes, like configuring my ports, my protocols. And as I'm going through that process, I'm expecting a certain state. And, that's part of my build process, is actually validating the state on the fly. Whereas if you did it the way I we talked about earlier, and I didn't have a strong opinion on, which is bring the config down, is you'd have to do a separate state validation after the fact, as opposed to being in line as to, push config, bring port up, expected state, pass or fail on the fly, versus load a whole config up and then do a whole audit basically after the fact to see if everything came up as you expected, right? So
yeah, that's a good point. And you're likely going to use one of those other management interfaces for your state audit. Let's hope you're not CLI tech scraping people. You know our opinions on that. Yeah, okay. So I guess, so two things here. I don't think there's necessarily a wrong way to go about doing kind of the initial configuration, other than you should try and optimize around code reuse. So if you are going to have kind of ongoing configuration deployments, you should likely try and stick to the same mechanism you're using for that initial deployment. Now, if that's loading a file, I'm not going to fight you. We all have our own battles, and maybe this isn't one you want to take up. But at the very least, try and be consistent is what my 2 cents would be here. I don't know if we should necessarily talk about the tooling. I think we'll do some follow-up podcasts on what is out there in terms of assisting you. And there's a bunch of open source tools, a bunch of projects out there. So we will do, I guess, deeper dives on the tooling that can enable you to do this. I think we'll try and cut above that for this particular podcast and try and cover the end-to-end network automation journey. Yep. So we've gone through design. We kind of skipped over that because it's mainly data center. But all that really entails is generating cable maps, and it's just plugging variables into some kind of algorithm that will likely then spit out a topology for you. If you know the data models and what kind of switches you're configuring at that point, you could also generate some of the base configuration. You're then pushing it down either via zero-touch provisioning or one of these other management interfaces that we've talked about previously. And I think that brings us nicely to kind of the ongoing change in the network. And there's a bunch of topics I think that loosely or not so loosely are relevant, like CI/CD and its place in networks and stuff. Maybe this is a good opportunity to start talking about some of those. And I'd be interested to hear your thoughts on kind of the role of, I don't want to say DevOps, but the role of driving the code of the network, which really is the configuration, through some of these kind of automation pipelines. Have you seen this out there at all? And have you seen it, I guess, be successful would be my next question.
Yes. There's not much of it out there that I know of, but I think there's a lot to... There's quite a few positives around doing it that way. But one thing that I do question is usually service creation is tied to something else, right? So you're building a service for a specific reason. And that is usually tied to another system. So whether that be like in a data center world, that may be some compute orchestration system like like a Kubernetes or a VMware or something else, where you have to create a matching service or an associated or supporting service on the data center fabric. Maybe it's in the WAN or in the service provider world that's tied to a customer product that you just sold them a VPN service. Maybe they're extending a VPN. So it's usually tied to something else. And so an isolated build pipeline just for service creation in a network, I'm not sure, but certainly if you had an upper layer triggering a build, like triggering a service creation, like you say, it's a billing system that is going to, like I said, create that service for that service provider for that customer. That triggers a build in a CI/CD pipeline, which includes obviously generating the correct configuration, validating states, maybe doing some service level assurance, all that as part of some sort of build pipeline, and then coming back and saying, "Hey, okay, the service is good." That would make sense. On the data center side, if you're doing more orchestration with, like I said, those compute platforms, you're not really going to have a build pipeline per se, because typically those compute platforms will be having some sort of like plugin to create the right networks, and they may require some external or some configuration on the switches, in which case you may want to trigger a build. But oftentimes it could be triggered by some sort of integration into someone creates a specific workload, and that requires you to create a certain network on your fabric. And then you would usually have an integration piece there with your fabric manager, which could be a pipeline. It could be triggering a pipeline. You could have that. But
I guess what you're saying is because that's such a repeatable task, and it's typically, I don't want to say templatized, but it's kind of defined ahead of time. You're hitting an interface, you're passing it variables in a lot of cases, and it is doing the rest. So maybe the necessity for some kind of pipeline at that point is a bit overkill, is what you might be saying, I think.
I think so. Yeah.
Yeah, I mean, I think the only argument there is the one I just made before around reusing code, right? Because if you do look at all of these APIs, there's two models here. One is push and one is pull. It's not that complicated. Where your network management platform, for lack of a more generic term, is listening on maybe some of the kind of like pub sub style interfaces that these like things like VMware and OpenStack with like RabbitMQ and stuff like that they expose, and reacting, or and I think this is the more dominant model, where you have like a proper integration with those systems, and they're doing a push. In which case, I think it depends on the speed of the pipeline, because and it depends what you're trying to accomplish with that pipeline, right? So. Let's say you're deploying a service. Your pipeline could be as simple as having like a spinning up a container image, which takes a second, and then pushing the configuration into the container. And does the configuration load successfully? Yay or nay? That could be stupid simple pipeline, right? And probably actually there's some value in that, in case at some point you try to do something silly like configure something larger than a 24-bit VNI, or larger than a hey, you never know, right?
You never know.
But that gives you some of and I know we've talked about this before in terms of being able to compile data models and stuff like that. That gives you kind of a level of certainty that the configuration that you're trying to push, at least, like, and obviously this is not data plane validation, people. We're not validating that there's space in TCAMs or anything like that, but you get kind of a checkbox, I think, and I'm all about checkboxes, because if you get enough of them, your certainty level of a change being successful goes up. Now, you don't want like the deployment of a new virtual machine to take 10 minutes, and 9 minutes of those are kind of your networking pipeline spinning up and going, what am I doing? Okay, I'm going to deploy some configuration.
But I also feel like when you integrate with those platforms is, especially if you're dealing with vendors, you typically have an integration into like some sort of fabric manager where, say you spin up a VM somewhere, and let's just imagine it's like SIOV or something, and you need to create a matching VLAN on that particular top of rack where that particular VNF was created. If you did not have a fabric, a vendor or other, but let's say vendor-based fabric manager that talked to, let's say, OpenStack, let's assume OpenStack was the one driving this VM and the whole network and all that, virtual network, then you could use a pipeline if you didn't have that. But most of the time, I would say you're probably going to have some sort of layer in between, like a vendor vendor management, fabric management system, which is then listening to that bus you were talking about from OpenStack, and then it is going to make a change, and then you're not necessarily triggering any pipeline. You're just reacting to another platform, which is kind of what I was trying to get at before, where there, in that particular case, you don't really need a pipeline. You could in parallel trigger like a pipeline to do some validation checks and ensure that what you expected to happen did happen. But I would say in those cases,
couldn't the fabric manager be the one triggering the pipeline?
It could be, but I don't think. What I'm saying is, I don't think it does. I think most of the time.
No, agreed. I don't think this exists very commonly today. I think we're in theory
land. Could it for
here.
sure? Okay,
Gotcha. Yeah, and I do think there is usefulness, and we're kind of at the cusp of this starting to become more mainstream. I think, we've seen it in tier ones. They've tried to leverage the same practices that they use for iterating and deploying and developing applications for all aspects of their business. So we're starting to see the stuff trickle into the network. There's lots of fancy words that get thrown around, like NetOps and NetDevOps and all that stuff. And I think there's a lot of different facets to this, but I do think a big one is the automation of testing. And I've always kind of had the philosophy that the configuration is the code of the network, and how do you test code? You run things like unit tests.
Right.
Or you do kind of functional testing, as many tests as you can do based on your tolerance for risk, right? Because like I said, you don't want something to take 10 minutes. Why is
that? You had the Mike Pence fly. The Mike Pence fly just showed up in your face.
I did, yeah. And I got all this nice lighting, so it was easy to see too.
Yeah, it was good.
Yeah, so I think there's always a trade-off, because you can do you could have a separate lab with hardware that's sitting there, and you're rolling all your changes. Every single change in the network rolls through that. Unless you have some kind of mission critical business where we would all say we have mission critical businesses, but I hope you get my point here, that we're always trading off delivery versus the risk of said delivery. So I think there's a degree of short wins, short checkboxes that we can go through. The fact that all these network operating systems are moving towards x86, and we have the ability to deploy them in containers and potentially load configurations against them and make sure they validate that they work. You could even take the existing configuration of the system and give that config some more context, because of course, just loading the change that the platform pushed to you only gives you a small piece of the puzzle. And this doesn't remove all risk. I don't think you can never remove all risk, even with having that hardware lab sitting there. But certainly, I think short wins that provide high levels of certainty are things we should all be striving for. And I think to quantify that a little bit, I named a few things. Containers and CI/CD pipelines for change into network. I think we should all be on a path to doing that. For some, it's not realistic, because you have, I guess, maybe network operating systems that aren't based on x86. You and I know of one in particular. So
yeah, I think more and more of them are becoming. You're right; they're not all there, obviously, today.
Yeah, yeah. So I think that would kind of be my step one is think about in general, when you're pushing a change to the network, that change always has implicit risk involved with it. Your job as an operator, as an engineer, as an architect is to de-risk those changes as much as possible. And I do think taking some of the practices that we have learned over on the application side of the world, they have real applicability to the network and how we drive change into the network. I think containers and having them as part of a pipeline is just one thing. And I think to your point, there's two ways to do this. One is you have like a fabric manager, like you were saying, and it is the one that does this, which super valid. I don't think there's any problems there. Or you spin up your own version of whatever this may be. And I think there's pros and cons there. I think having a self-contained pipeline is definitely useful. It's kind of how the application runs.
Especially if you integrate the test aspect of it, which is often overlooked, I think. Like I said, if you use the fabric manager, maybe it's doing some test validation, but I don't think it's doing as much as it should be or could be doing. And certainly having your own testing against a change or a service both, as you said, in a maybe containerized environment prior to the actual production push, but then also once you go to production push, executing those tests against that to validate that the changes you made have expected behavior is a key aspect of what you would do as part of your pipeline.
Yeah, definitely agree. All right, so that's one of those generic mechanisms that I think helps with this. Maybe if we were to double down on some of the hows, and I don't want to talk about projects here today, but there's certainly a couple of recent ones that have caught my eye that I've played around with. And these are not so much on the network automation side of things, because really they are just about enabling the pipeline aspect of this. So one we've been using for a while is Docker Topo. I think it was started by some Arista engineers. But obviously they're running Docker containers, and all this really is the ability to stitch V pairs between containers to bridges and then have things connect nicely. And just recently, another project popped up that I thought was really interesting, which was Container Lab. So I definitely recommend our friend Roman Doden is one of the developers over there that's been working on that. Looks really, really promising, especially coming from like the networking side of the fence, the ability to kind of spin up these simple or even complex topologies using containerized versions of the network operating systems that we likely have deployed in production anyway. So definitely go give both of those projects a check out if you're in this space and you're looking for ideas.
And I was going to say Roman's a bit of a machine. He's got a bunch of projects that are kind of cool out there. He has a bunch of GNMI projects. He created a GNMI based CLI that reads in Yang models, and anyway, I would recommend checking out his GitHub, and or associated projects. Yeah, he's got some cool stuff on there.
Yeah, if you're into network automation, I think his handle on Twitter is NetDevOps. So
kind of gives it away.
It does a little. All right, so moving on. I think we've covered the first three. I mean, we didn't so much talk around the building of services and stuff, but we did indirectly, I think, around the hows and the whys and what is triggering those changes and what are some of the potential risk mitigations you can put in place as an operator. The last one, and as you said, this one is the really, really interesting one for me because it's one that there's so many different ideas around. There's no really bad ideas when it comes to operations unless they affect the network. So, and that's relatively easy to do as long as you design things well. You named a couple that I thought were interesting, like one-off scripts. I think they're always going to have their place. You have that task, your manager calls you up at 1 a.m. and for some reason you're awake because you're just a night owl, that kind of guy or gal. And he's like, hey, I need you to go and pull all the error statistics from our entire network. And then I need you to do it again in 5 minutes and see how much they've incremented.
Exactly.
And you're like, okay. So you scratch your head for a little bit and you're like, okay, I need to write up some kind of script. Ideally, you're not tech scraping people, but maybe you could be forgiven for doing it for this little one-off. This
is the problem. Wait, stop. This is the problem. This, like that sentence, that statement is the reason why we're stuck with tech scraping is because, you have that one-off script. It's a very quick thing. I'm just going to pull off, check out the stats on VLAN 25 across all my devices. It's fine. Just for this one script, I'll just text scrape the CLI and I'll get the output I want. It's the easy win, right? Which it may be, but it doesn't help you build that skill set and push the industry to moving beyond that and using a proper interface with a proper data model, which once you start doing that, you can retrieve that data just as quickly, if not more quickly than parsing the CLI, right? But it just seems like the fact that it's easy because that's what we know is really what's holding back the industry from properly consuming a network operating system data model and interface, whatever that interface may be, netconf, GNMI, whatever, right?
So I would caveat that by saying I did mention this was at 1 a.m. So
okay, fine. Okay.
There was an implicit tone of urgency here, but yeah, that actually does highlight a good point in that. And we talked about this in the netconf v GNMI episode. So I don't want to rehash the entire discussion, but one of the big issues that we saw with netconf, and GNMI has this same problem, I do believe, in that the interface and the implementation of that interface is complex. So if you get that kind of one-off task and it's something you're gonna write the code and you're likely gonna lose it before the day is out, You're going to implement the thing once or twice and run it once or twice. You tend to like have that knee-jerk reaction to quick and dirty rather than do it properly. Now, even then, you could argue that the correct way to do this would be through a RESTconf style interface. So even what I said is I'm going to give myself a slap on the wrist.
But even I mean you've done this, but even setting up, let's say setting up GNMI, right? It's maybe more involved than a REST call, right? Sure. But it's not that much more involved. Like, it's not like you have like a mountain to climb just to get a connection out to your, I mean, you have to manage certificates. I mean, there is a barrier of entry there, but I think if you have a proper operating model in place where you've done it once, then doing it twice, 3 times, 100 times is not that complicated. And that barrier of entry to whip up that script is a lot smaller after you've gone through the motions the first time.
For sure, yeah. And just plumbing in an XPath into something that's doing like a GNMI get or something like that is definitely going to be easier than doing a text scrape and trying to dump data.
Exactly, and then
grep it,
parse out your stars and your brackets and your thing just to get the info. When you could have a properly formatted JSON response and you just retrieve the data you need, right?
Yeah, you make a good point. You do make a good point. Don't do text scraping, people. Erwin is very, very against it. So I think those kind of automations do exist. Now, whether or not they could execute, like, because what typically happens, and this actually kind of does link back to what we were just talking about. You do it once at 1 a.m. You get that request that gets fired in. There's some there's some random outages that are happening, and people are trying to figure out what's going on. And someone has the idea that they saw a CRC error increment somewhere, and all of a sudden you now need to check for CRC errors across the entire network.
Yep.
So you quickly write up the script that does it. Let's assume you did it properly and you did it using one of the model-driven interfaces and you didn't text scrape it because you're a good network engineer and you like to do things properly. So you now run it once, and 5 minutes later you run it again, and maybe that's the end of it. I think in a lot of cases it's not, because everyone's like, hey, we saw those 2 errors incrementing. This was really useful. How about you just shove that into a cron tab somewhere? And Bob's your uncle, automation, baby.
Now we got cron as part of automation.
Oh, cron's always part of automation. Cron ain't going away.
Right. I like it.
So I think those one-off scripts probably aren't going to be one-off. Now, there are some that end up doing deployment stuff, and maybe those are actually one-off. But typically, a good example to speak to some real experience, I wrote this massive, I'm going to call it a program. It wasn't even a script. This thing was a Perl program. It was like hundreds of lines of
executable.
Perl. You're damn right.
And a binary that you executed, and it.
I'm compiling Perl. We're living in the 21st century. No, so it was a very, very, very complex Perl program that was deploying, let's say, tens of thousands of services in the network. And that then took a long time to build, long time to test. And I definitely did build it for a one-off, because the idea was once all the services that are built for this, this particular deployment were done, you throw away the code and you start fresh. You move on to your next project and you're away laughing. But I think, as we all know, when you're starting to write these things, you'll get another project and there'll be a piece of it that is like close enough to something you did, and you end up pulling that code along, right? So I guess the story is here, it's never just once off, or even when you think it is, it's unlikely that it is. I was just harping on about code reuse, right? So, and that's the way we all kind of operate. I think we all kind of, I don't know. Would you agree that code reuse being what it is, there typically never is a one-off deployment of something or a one-off use of something? I never say never.
You never say never, but you're never going to throw away that code and never use it ever again. You're going to build your own internal Stack Overflow.
Well, never say never.
Never say never. Exactly.
All right. So yeah, on the operations side, these one-off scripts, they do exist. Try to imagine them as you're writing them as if they're not one-offs, even if you think they are. Just think about you wanting to use it in a decent amount of time later, because I've made this mistake too of writing code and putting it on a shelf for 6 months, And then you look at it again, and the use case is so specific that you're like, oh, what was I doing? Because it's amazing looking back at code you wrote just 6 months ago and going, I was an idiot.
also, when you write those one-offs with a one-off mentality is, well, I don't, maybe others do, but I don't tend to comment my code. And so when I do come back to it 6 months later, I will be like, what was I doing here? Yes, I have to go back and reread everything to understand which functions were doing what. But yeah, sure. So if you mentally don't treat it as that one-off, you tend to probably write better code, maybe spend that extra 5 minutes to write the proper comments, so that when you come back to it in 6 months, you can actually reuse some of it in a more efficient manner.
Add some logging,
maybe some logging in there too. That'd be nice. Yeah.
Okay. Anyway, I don't think we want to teach people how to code, because neither you or me are actually developers. So
I'm awful.
So we'll move on or away from one-off scripts. I think we covered some of the other topics I had under my kind of operations bucket, which were around, CI/CD for configuration, leveraging containerized versions of your network operating systems to kind of help with that. Some of the projects. The one that we didn't cover, I know it was on your list too, was remediation pipelines. So we're still on pipelines.
To be fair, is on my list because you and I have talked about this before. And I'll be honest in that I don't really know much about what's out there to do this, and I've never tried implementing this, so I don't have much of a background to talk intelligently about it.
Okay,
so
no, I think that's fine.
Let you lead here, and I'll comment as we see fit.
No, that's good. That's good. Because I think how I kind of break remediation pipelines down, and this is definitely a problem that is exacerbated by scale. And the reason I say that is if you have a 4-node network, you probably don't need any kind of pipeline to deal with remediation. Maybe you do. But what I at least really mean by like a remediation pipeline is, look, we have hundreds, thousands of events that occur in the network every day when you deal with some of these larger scale networks. In some cases, the remediation is simple. It's this is a spine within a data center. It is dropping traffic in some kind of undeterministic fashion. You drain traffic from the spine and you try to resolve the problem, right? So remediation is more about resolving a service outage. It's not necessarily, you certainly can get more complicated and solve actual problems. Typically, if an automated remediation is going to be able to solve a problem, that's probably just a bug, and you should probably just fix the bug. So I do see them more used to recover service in the event of some kind of outage, and that basically means that you're relying on redundancy in a lot of cases. Sometimes it doesn't. A remediation could just be go and reboot a box. And what I mean by the pipeline aspect of it is, just imagine you have this big telemetry interface, and it's sucking in tons of data. And in fact, I'll even go so far as to say that it's mostly sucking in events. Now, I think once you start feeding in error statistics and things like that, and maybe you have some probes in the network, so you're measuring latency and jitter, and maybe you can, at least with a degree of certainty, try and isolate what is causing higher jitter or high latency down to a single hop within your network, then a remediation could just be to reboot that box, drain traffic first and reboot the box. And that could happen in an entirely automated fashion. There's this whole concept around engineering chaos in networks, which I think is really important. Not that your remediation pipeline should be engineering chaos, but the point there is, you should have breaking points, or you should be trying to force breaking points in your network to find where the outer bounds are and where you need to potentially do additional engineering to try and solve for problems that you don't see all the time, that you see sometimes. So the basic concept of a remediation pipeline is you deal with an issue, you find a set of reproducible kind of characteristics to isolate that issue, as in, I know what is wrong here. One of the line cards has some CRC errors. There was a solar flare, and anything like that. And you then perform some kind of remediation. Now, remediation ideally means resolving service, as in what to do in order to bring things back. But sometimes the remediation could just be send a text to Erwin and he'll come and look at it. So
or more more recent is this big influx in chatbots, right? Where you tie your operations to these operation chatbots in Slack or Teams or whatever chat application you're using, and you can have it ask you to do things or perform operations on a network or alert you or whatever it may be.
Yep, exactly. So high level, that's all a remediation pipeline is, at least in my book. It's finding something that you are able to resolve as a human, as in, A plus B equals C.
That's repeatable. That is
repeatable.
Exactly.
And you drive that using events into a pipeline of some sort.
Speaking of the human aspect, what if you introduce like a mechanism like machine learning of identifying faults and having it flag a common fault across all your switches and having a human decide what the action may be to remediate it, but not necessarily needing that first fault to occur and be catastrophic for a human to be alerted to do something on it, but actually a trend maybe need to be alerted.
I mean, this is utopia, right? This is like Skynet.
Could you imagine?
No, I mean, I think we're starting to see some of this already. And to be fair, it's like the most basic of machine learning, where you're trending something over time and looking at the rate that it increases, and then you're having thresholds built into that. And the typical one is like I guess dB loss on fibers, right? Past a certain point, you're going to start to see errors, and if you can graph or otherwise perform some statistics on that loss happening, you can often predict that a fiber is going to go bad before it goes bad. That's real. Right. That's just science, baby. So I think it's relatively like you need to be living in a sort of utopia with a lot of resources in order to spend time building out that kind of stuff, unless you're buying it from a vendor who are going to make money by selling it to you. And I'm sure if we looked in some of these big tier 1 networks, there's some, if not a lot of this stuff going on. Because
there was a talk by Google at Nanog earlier this year, and someone asked them the question during the question and answer period at the end of their talk about whether they were using machine learning to discover faults in the network, and they gave you the classic, well, we can't talk about it, but wink, wink.
Yes,
wink. Exactly. Yeah, exactly.
Yeah, so I think we will get there as an industry. Like I think this is realistic within my lifetime. Granted, like the networking industry is probably only just a little bit older than me, but we've come a long way since I was born. No, but I do think we're on a path to solving more and more problems without operator intervention. And I think machine learning is one aspect of it. I think what I was talking about, where you have event ABC occurred, and I know that means I need to do XYZ, and then automating that and plumbing that into some kind of event pipeline that is able to do it automatically. I think all that stuff either exists today. No, it does exist today. I think it'll become more mainstream within the next couple of years. To the point that maybe we drive all networks this way. I don't know.
Automagically?
Just magic. No engineers required.
Self-healing, self-designing.
Or putting ourselves all out of jobs. It's terrible.
Yeah, absolutely. Yeah. Rest in peace, network engineers.
Yeah, thankfully we're not there yet, guys.
I had maybe this will be a topic for a future podcast about the who was I talking? I was talking to someone about this recently, about the term network engineer. Was it with you maybe? Network engineering and a network engineer, and how the majority of network engineers don't engineer anything at all.
Yeah, you were talking to me about that.
Was it about you? Okay, was it you? Okay. So I think we should have that conversation sometimes on one of these best efforts, because I put more thought into it, and it's a good topic.
It is a very, very good topic. I think there's a distinctive difference between an engineer and someone who implements solutions, which is going to be the entire foundation of that podcast.
Which implements vendor solutions.
No, you can have network engineers that use vendors. All right, they exist, but
no, I'm not saying that. I'm not saying that all network engineers are not engineers and not using vendor. And you can't use it. If you use a vendor, you're automatically not a network engineer. I'm saying, oftentimes the architectures are derived by vendors pushing
that's
their
fair.
Own.
That's fair. Yeah. Here is the design you're using, and here's the equipment, and here's your cable map.
And here's why. Yeah, and they'll give you some valid reasons to why. But anyway, that's a different podcast.
Yeah. Let's not alienate our audience just yet. Let's.
No, exactly.
Alrighty.
We love you all. You're all engineers.
Absolutely. So, all right. I think this was a good context set for the various aspects of network automation. Now, you probably expected us to talk about SDN here, right? I think someone was like waiting for us to say SD-WAN or just SDN in general, or to talk about intent-based networking.
Yeah, we did allude to intent-based network. I mean, there was like we didn't say the word intent. Validation. Yeah. Yes, exactly. So there was a throw out there to the intent world, but.
Yeah, so I think that actually wasn't intentional, by the way. I'm just realizing it now that we didn't say SDN or intent once in this podcast until now.
High five.
Everything, I know, dude. We definitely deserve like a pat on the back for that. Because these are marketing terms in a lot of cases for what are generally relatively simple solutions underneath the hood. Now, the complexity is in the matrix, to be fair. So, and that matrix is definitely real, and the level that you're validating state is important. All that good stuff.
Relationships.
Everything we talked about today was SDN. Was software driving software, right? So it was all SDN. Aaron mentioned state validation when we were talking about containers and pushing a configuration and validating the result when you're doing ZTP. That's intent, guys. Now, abstract intent and simplifying it, making it human readable, that's another topic for someone much more abstract than you and me, I think.
Yeah, like correlating state and correlating relationships between objects. Like there's much more to it, but at a very high level, that was intent without saying intent.
Yeah. So kudos to us. Kudos to the listeners if they picked up on it too. Yeah, hey, they're talking about intent right there. That was intent.
I read a blog post about that.
Yeah. We're probably going to end up writing a blog post about that.
Yeah. By the way, we need to get on that because we claimed in our We're Going Live blog post that we'd have a bunch of written content, and so far we have exactly 0 written content.
Yeah, we're spending all our time delivering these amazing podcasts for people.
That's true.
Yeah.
Plus, I'll be honest, I find these more entertaining for me. I mean, it's easier for me and it's more entertaining to sit here and talk to you than it is for me to sit down and write stuff. That being said, I do have like 3 or 4 topics in the works.
Things. Yeah.
Yeah, in the works. So we will have written content, which hopefully is interesting and useful coming out soon.
Yes. They'll be more practical, I think. I don't think if we're just trying to discuss things, I think this is a better forum for that. The audience, it's easier for them to listen to it. So.
Although I think I will be including some opinion. I mean, I definitely plan on including some technical stuff in the blog post where it'll explain things technically and it'll be more useful and practical to people. But in some of the stuff that I've written already, I feel like I'm also including some opinion pieces in terms of how and what should be used. So
for sure, I think that's why it's interesting. Otherwise, people could just go read the manuals, right?
Correct.
So, all right. I think we can wrap it there. Hopefully this was interesting for you guys. There will be a lot of follow-up topics on network automation. Like this was intentionally scratch the surface, broad strokes, what is going on.
Yep.
All that good stuff. So we hope it was
we'll talk about tools.
Yep.
Applications you can use, frameworks we can use. We'll go a little deeper in the next few episodes.
Yep, sounds good. All right, thanks for tuning in, guys, and we will catch you in the next one.
See ya.
Hey, everyone. Thanks again for tuning in. As always, please do let us know any feedback or criticisms you may have. We can be reached on Twitter, YouTube, or our website, ntwr.kn, where you'll find this episode and many others posted. For those of you on YouTube, if you liked the episode, please hit that thumbs up button. And if you didn't like the episode, feel free to hit the thumbs down button twice. On a side note, you know those cliche, these are our opinions and not that of our employer statements you hear all the time? Yeah, we unfortunately have to make one of those. The benefits of working in the industry we want to publicly have an opinion about. We've done our best to remove bias, but we're only human and we make mistakes just like you. Thanks again. We'll see you in the next one.